This video is solving trig function, so it's still from section 13.4. However, it's going to walk you through how to solve a trig equation using inverse trig functions. And if you watch the intro video, recall that for an inverse sine, you're restricted to quadrants 1 and 4. And inverse tangent, you're also restricted to quadrants 1 and 4. And inverse cosine, you're restricted to quadrants 1 and 2. So if I said, find where, or inverse sine of theta equals 1/2, you know where that occurs, but in first and second quadrant, but you would only list the first quadrant answer because of that restriction. What I'm going to do here is we're going to solve trig equations using the inverse trig functions. However, you're not going to have these restrictions. So please understand that there are two different equations, and you'll understand when you don't have that restriction because I will literally tell you. So note this, these equations, are all calculator questions. And the first one says solve the equation cosine theta equals 2/5, where theta is between 270 and 360. Okay, now I want you to think about this right here. It's basically going against all your cosine restrictions. So if you recall, where a cosine value occurs has to be in the first or second quadrant. Well, this theta between 270 and 360 is in the fourth quadrant. So basically this is telling you just ignore those restrictions and make sure that this angle is occurring right here in the fourth quadrant. Okay, so what I do first is figure out what theta is, and you should know that you can use your inverse trig function. So if I do inverse cosine of 2/5, that's going to give me theta. So if I make sure that I'm in degree mode, because these are in degrees, right? And I do inverse cosine of 2/5, I get theta equals 66.4 degrees. Well, obviously, that's in quadrant 1, right? And I want to be in quadrant 4. So if I kind of visualize this, I know that 66 degrees, I'm just going to kind of approximate that, is right here. But I want it to be in quadrant 4. So I'm basically going to take that same angle but reflect it down into quadrant 4, right? So this is the same. Now think about cosine is an x coordinate. So if I go over and down, this x coordinate right here is going to be the same if I had gone over and up, right? So it's really the same exact cosine value will give you this terminal point or this terminal point, but I want that terminal point because it's in the fourth quadrant. So how do I get there? I could do negative 66 degrees, but then I'm not falling within this restriction. So how do I get over there and make sure that my angle is between 270 and 360? Well, I'm going to start at the origin as my initial side, and I'm going to get over there this way. So how I got there now is basically probably the easiest way would just take 360 degrees and subtract off the 66 that I don't want. So if I take 360 degrees minus the 66.4 degrees, I get 293.6 degrees, and that is the angle that I want. So again, let's just kind of make sense of this. Once you get your angle in the wrong quadrant, you kind of make sure you place it in the correct quadrant and make sure that the cosine value is identical in that quadrant, and then figure out how you can get there. So I could take 180 plus 90 plus whatever this angle is, or I could take 360 minus that 66 degrees, which is what I did. Just really think it through. Okay, so I'll kind of go through this one a little more quickly, but note again, it's sine of theta equals negative 0.62. So first and foremost, I'm going to figure out where the sine has a value of negative 0.62. So I'll inverse sine to figure out theta, and I get negative 38.3 degrees. Okay, so I want my theta, which is in degrees, note, to be between 180 and 270, so that would be the third quadrant. Right here, I'm in the fourth quadrant, right? So I'm going to kind of visualize this. right now, my angle negative 38 degrees-ish. I'll estimate that, so that's negative 38 degrees. I want it to have, now think about sine, right? Sine is y. So I want this distance to be the same in the fourth quadrant as it should be in the third. So I'm going to draw that angle and make sure that right here that that's 38 degrees also, because they have the same y or sine value, right? They're both negative. So I need to figure out how to get between 180 and 270 and land on that terminal side. So again, starting at the initial side, how do I get over here, right, to get to that angle? Well, that's obviously pretty easy to see. So I'm going to take 180 plus that 38.3 degrees, and that's 218.3 degrees. And that's my theta in between 180 and 270. All right, one more. So where's the tangent equal to 3.2? So first, you'll inverse tangent of 3.2 to figure out what theta is. Dump that on your calculator in degree mode, and I get 72.6 degrees. That, obviously, again, in quadrant 1, I want my angle to be between 180 and 270, which is quadrant 3. So, visualizing this, 72, I'll just round that to 73 degrees. That's the tangent value, which is y over x, right? So this point right here should have the same tangent value down in the third quadrant as this one. So this should also be 73 degrees. So basically whatever angle you find over here, really it's just a reference angle. So go to the quadrant you want, connect it to the x-axis and turn that into a reference angle. And then of course you have to ask yourself, okay, how do I get there? So starting at my initial side, I want to end up right here. So I can take 180 plus 72.6, and that's going to be 252.6 degrees.